Hello and welcome back. Today we're going to start adding and subtracting rational expressions. Last week we did multiplying and dividing. Adding subtracting is a little bit different, just like it is in regular fractions. So if you remember, with regular fractions, we have to find common denominators. Okay, so just like when we add regular fractions here between 5 and 7, we would have to find a least common multiple between 5 and 7, which would be 35. And so we'd find our, least common multiple between 35. And that would be, we have to multiply this one by 7 over 7. So we multiply top times top would be 7, and that would make 7 times 5 over 35. 7 would go into 35 5 times, so we would multiply top and bottom over here by 5 over 5. So 3 times 5 is 15, and 7 times 5 is 35. Then we can add the numerators, 7 plus 15 over 35, which would give us then 22 over 35. And that's how we add our fractions. We do the same thing when we're talking about our variables. Okay, so if we want our common denominator here is going to be xy combined, right? Xy plus something over xy. I'm going to have to multiply this one by what I'm missing, y over y. So then 1 times y would be y, and then y times x is xy. Over here, I would multiply by x over x. So 2 times x would be 2x. And then y times x is xy. So when I add these two together, it would just be y plus 2x over xy. The denominator stays the same. Okay, so a very similar process as a regular numerical fraction. Okay, so this is just kind of the basic fraction rules. If you look, when we add, we have to have a common denominator here, and then we just add our numerators and we keep our denominator. Same thing with subtraction. We subtract our numerators, keep our denominator. Remember, when we multiply, we just multiply straight across, top times top, bottom times bottom, done. When we divide, we flip our second fraction and take a over b times d over c, and then do the same thing, top times top over bottom times bottom. Okay, so let's look at adding some of these fractions then. How do we add this particular one? We already have common denominators here, right? X plus 4 and x plus 4. So no need to change the denominator. We're just going to go ahead and keep our common denominator of x plus 4. And we're just going to add the top, x plus 5. Add the numerator, keep the denominator, and we are done. Okay? We're not going to worry about restrictions in this particular time. We're just going to learn how to add and subtract. Okay? And again, over here, kind of comparing the similarities between adding numerical fractions and adding rational expressions. Okay? We add our numerators, keep our denominator. Okay? What is the sum here? Well, it looks like they don't have common denominators, but again, if we use our factoring, we can take this in 2x plus 1 over, we're going to factor this out as, x, factor that x out, x times x plus 3. So now that gives us our common denominators over x plus 3. So we can add those together, giving us, we're going to add just the top, so 2x plus 1 plus 3x minus 8 over our common denominator, x times x plus 3. And we just combine our like terms. 2x plus 3x is going to give us 5x. 1 minus 8 gives me minus 7 over our common denominator, x times x plus 3. And we are finished. Okay? And so that is basically how you're adding your fractions. So you guys go ahead and try this. You can turn off the computer or pause the video. Turn off the computer, don't do that. Pause the video and then come back and see how you do. Okay, so all we're going to do, we have a common denominator. We realize that, so we're just going to add 10x minus 5 plus 8 minus 4x all over our common denominator of 2x plus 3. That's going to give us our 10x minus our 4x, which is 6x. And then negative 5 plus 8 is a positive 3, all over 2x plus 3. Remember, we cannot cancel that 3 or the 2x and 6x because they are not products, they are sums. We cannot cancel those. Do not do that. Every time you do that, a kitten dies. Okay? All right, so now we need to, when we don't have common denominators that are the same, we have to find what's called least common multiples. So first we're going to practice finding least common multiples, and then we'll put it to use, okay? So find the least common multiple between x plus 2 squared and x squared plus 5x plus 6. First of all, what we do is we factor each polynomial. So x squared becomes x plus 2 times x plus 2. X squared plus 5x plus 5 becomes x plus 2 times x plus 3. And this should actually be 6 right here. I don't know what happened there. Okay, x plus 2 times x plus 3. And then what we do is we take and look at which ones do we have that are the same, right? We have this x plus 2 and x plus 2 are the ones in common. When we have the ones in common, we just keep only one of those, right? So x plus 2. That's one of our common denominator factors, okay? Then the ones we don't have in common, we have to add those to the process, what's missing. So we have to add an x plus 2 as one of the factors, and then we have to add one of our x plus 3s as one of our missing factors as well. And that becomes our least common multiple right here, okay, between those two. That is my LCM, okay? So you have to factor them all out. Whichever ones you have in common, you only put those in one time, okay? And then you have to ask what's missing, and you add all those ones that are missing, the additional ones, okay? And so now let's go ahead and find out what is our least common multiple between these three terms here, these three expressions. So we'll factor out this guy here is going to be x times x squared minus 9. That will factor even further to x times x plus 3 times x minus 3. The second guy here is going to factor to x minus, what's that? X minus 5 times x plus 3. And the last one will factor the x out to x times x minus 5. And if we look here, we don't really have, they have to, all three have something in common. We know that the x has something in common here, but only with two of them. Where we have x minus 5 has something in common here, but only with two of them. So none of them, like all three of them don't have something in common at the same time, right? The x plus 3 has something in common there together, but not all three of them have the same thing in common at the same time. So it looks like we have to have one of these factors all together at the same time. So we have to make sure we have an x in there. We have to make sure we have the x plus, oh, I got the wrong color there. X plus 3 in there. Okay. We have to make sure we have the x minus 5 in there. And then that kind of last standalone one right there, that x minus 3. So every one of those factors, we have to make sure we add in there for our LCM, or least common multiple. Okay. So you guys go ahead and try and see if you can find the least common multiple between these two expressions here, and then come back and see how you do. Okay. So x squared minus 4 will factor into x plus 2 times x minus 2. X squared plus 5x plus 6 will factor into x plus 2 times x plus 3. Now these ones, we do have a couple that are in common. We have this x plus 2 and the x plus 2 that have in common. So we'll only need to add that one time because it's already common, right? Common factor, least common multiple. Kind of think of it that way, okay? Then the other two are going to have to add an x minus 2. Because that's going to be missing, that's part that's missing, and we're going to have to add an x plus 3 because that is missing, okay? And that's how you find your least common multiple right here. And there you go, okay? That's my LCM. So that's kind of what we're going to be doing when we have to add and find a common denominator, all right? So now we're going to start with this. So we're looking at these two here, and we're going to first of all factor the denominator so we can find our least common multiple. So we have this x plus 3 over, I'm going to factor this guy to x plus 1 times x minus 1, okay? And we're going to, let's find the sum, so we're going to add, and then 2 over, I'm going to factor this guy. It's going to be x, what is that going to be, minus 2 and x minus 1, okay? So those are a couple of factors. Well, first of all, let's come over here. Let's look and see what our LCM is, just kind of bringing it over here. You don't have to do this every time. I'm just going to do this for this one. And then I'll show you a little bit of a shortcut, okay? So what is our least common multiple? So first of all, which ones do we have in common? So we have this x minus 1 and the x minus 1 that we have in common. So we only need to add that one time because it's in common, okay? These other two, we have to add this x plus 1. And we have this x minus 2, okay? So this is our least common multiple right here. This should be our common denominator, okay? So this is my LCM. or are also our common denominator. Okay, I'm gonna write on my snowman here. Okay, so when we're trying to find a common denominator, what we have to find is what is missing. We have an x plus 1 and x minus 1. We're missing this green one, this blue one, this x minus 2. So what we have to do is we have to multiply this fraction by x minus 2 over x minus 2, just like we would in a regular numerical fraction. So if we multiply it by x minus 2 over x minus 2, that's the same thing as 1, so we're not changing it. Okay? Then we look at this other fraction, we have x minus 2 and x minus 1. Which one is missing? It's going to be the green one, right? So I'm going to multiply this one by the green one, x plus 1, on top and bottom. We can't just multiply one on the top and one on the bottom, right? We have to multiply top and bottom, okay? So then we're going to multiply those two. Now keep in mind that this is a binomial on top, so I need to put this in parentheses. So when I multiply those two, I multiply them properly, okay? That's going to be a FOIL. So x squared plus 3x minus 2x minus 6 over, and we have all this here, x minus 2, x plus 1 times x minus 1 plus, and I'll multiply this, 2x plus 2. And I'm going to write all this out, x minus 2 times x minus 1 times x plus 1. And a little side note right here. Everybody wants to start factoring and canceling things out right here. Keep focused on what you're trying to do here. You're trying to add rational functions here. So we don't want to cancel things out. We want to keep our common denominator, right? So don't cancel things out. And usually what we do here is we usually simplify the top and we leave the bottom factored, okay? So we're going to simplify the top here, multiply it all out. So we have x squared. We have these two x's cancel each other out, okay? So then we have just a plus of 3x and plus 2. And we have our common denominator, x minus 2 times x plus 1 times x minus 1. Now we are going to check and see if we can, this is our finished result, right? We are all added together. Now from here, we can see if we can factor and cancel. That's okay. So are there factors of 2 that add to 3? And there are. You have x plus 2 times x plus 1 all over x minus 2, x plus 1, and x minus 1. And in this case, my x plus 1s are going to cancel out. And that's just going to leave us with our x plus 2 over our x minus 2 times our x minus 1. And we are fully added. Okay? Want to make sure we get them all added before we do any kind of factoring and canceling. Okay? And that's how you add. Now, you don't always have to find the LCM over here separately all the time. Okay, I can kind of show you a little shortcut on our next page. Okay, so we're going to start over here by factoring x plus 6, x minus 2 times x plus 2. And then plus, and we're going to factor this guy. Factors of a positive 6 add up to negative 8. Be careful, these are always tricky ones. So this is going to be x minus 2, x minus 3, because negative 2 times negative 3 is a positive 6, and negative 2 minus 3 is a negative 5, okay? So now what the shortcut is I'm going to look over here and see what is missing in my factors, okay? So I have this common negative 2, right? I have this negative 3 that I'm missing, and I have this x plus 2. Well, over here, this one's missing the green one, so I'm going to multiply this x minus 3 on top and bottom. Okay, and again, my binomials, I like to make sure I keep them in parentheses so I don't forget to multiply them as binomials. Okay, then over here on this side, I look and say, oh, I'm missing this blue one. So I'm going to multiply this by my x plus 2 over my x plus 2. Okay, so colored pencils might help you with this little process. And now I'm going to just multiply. I'm going to multiply the top, keep the bottom factored. Okay, so I'm going to say multiply top, keep bottom factored. Keep bottom factored. Sometimes it's a chore writing on this screen. Okay, so we have x squared plus 6x minus 3x minus 18 all over, I'm just going to write this as x minus 3 times x minus 2 times x plus 2. Plus, and I'm going to distribute this 2 here. Bada boom, bada bang. So we have 2x plus 4 all over x minus 2, x minus 3 times x plus 2. So we have common denominators now. We have all of our factors there. We got to close my parentheses there. Now I can start simplifying on my top. Okay, so we have an x squared. We have a 6x minus 3x gives me a 3x plus 2x is going to give me a positive 5x. And then a negative 18 plus 4 gives me negative 14. And we have our x minus 3, x minus 2, x plus 2. And I'm going to see if I can factor this any further. I think I can. Factors of negative 14 add up to positive 5, I think are going to be x plus 7, x minus 2, leaves me with an x minus 3, x minus 2, oops, minus 2, x plus 2, and my x minus 2 is going to cancel out with that x minus 2, and that's going to leave us with an x plus 7 over x minus 3 times x plus 2, and there we go. Okay, and there you go. Okay. So let's go ahead and keep going here and just find our common denominators. So I'm doing lots of practices today, so I hope you guys can catch along here. So we have this 2x. I'm going to factor this out here over 3x plus 4 plus, we got this 4x squared minus 11x. We don't need to factor the tops when we're adding and subtracting because we only need to find common denominators, okay? This one here we're going to have to factor. So factors of negative 24 that add up to 5. What's that going to be? It's going to be positive 8 and negative 3, right? So we're going to have our, I'm just going to factor this over here. We're going to have 6x squared plus 8x minus 3x minus 4. I'm going to group those together. I'm going to factor out a 2x, which leaves me with a 3x plus 4. I'm going to factor out a negative 1, leaves me with a 3x plus 4. So over here, I should have my 3x plus 4 and my 2x minus 1. That'll save us some time there. Okay, so now I realize I'm going to go ahead and put these binomials in groups there. I have a 3x plus 4 and a 3x plus 4 in common. The one is not in common is the 2x minus 1. So I need to multiply top and bottom, 2x minus 1. Top and bottom, 2x minus 1. Over here, I don't need anything because I already have now both of what's in common and what I needed to add. So I have a common denominator now. 3x plus 4, 2x minus 1. That is my least common multiple. So now I'll multiply top and bottom. So I'll distribute this 2 through here. So I have 4x minus 2 over my 2x minus 1. That's minus 1. Times 3x plus 4 plus 4x squared minus 11x minus 12 over 3x plus 4 times 2x minus 1. Okay, now I can combine my slight terms on top because I have common denominators. So I'm just going to add the top now, keep my common denominator. Okay, so 4x squared. I have 4x and negative 11x, which gives me a negative 7x. Negative 2 and negative 12 is negative 14. All over my 2x minus 1 and my 3x plus 4. Okay, now I guess I can see if this is going to factor here. So we could say, let's see, 14 times 4 is 56. 56, negative 56, to add up to negative 7. let's see, what would that be? It's going to be, let's see. I don't know, 56. And I don't think that's it. I don't think we have any that's going to be that factors of 56 to add up to -7. Let's see here. Yeah, I don't think so. Okay, so that is it. This is our simplified version. Okay, there you go. All right, so now we're going to look at a difference. And difference is pretty much the same thing. The only thing we have to be careful is distributing the negative when we subtract. Okay, that is just the biggest difference. So I'm going to go ahead and do the same thing where I factor my top or my bottom, excuse me, so I can find a least common multiple. So factors of 16 add up to -6 is going to be x minus 8 times x plus 2. And I'm going to subtract, and I'm actually going to make this subtraction red just so I can say, hey, watch out for that. Okay, and then on top, x plus 1 again. And then factors of 8 that add up to 6 are going to be 4 and 2. So x plus 4 times x plus 2. I'm going to do the exact same thing where I say, what is my common factors, which in this case is x plus 2, right? And then I have an x plus 8 here, and I have an x plus 4. Those are the ones that are different, okay? So over here, I'm missing the 4, the blue one, at x plus 4. I want to multiply top and bottom by x plus 4, top and bottom. And I want to also make sure this binomial is wrapped in parentheses so I multiply it properly. And I'm going to go ahead and do that over here also. Okay, I'm missing the green one over here on this other side. So multiply x minus 8 over x minus 8. Okay, now this subtraction sign. Okay, I'm gonna hold off on that one for just a moment. So let's go ahead and multiply this top and bottom here. So we have x squared plus x plus 4x plus 4 all over my x plus 4 times x minus 8 times x plus 2. And I'm going to keep that red negative sign, minus, okay? And here I'm going to have x squared minus 8x plus x minus 8 all over x plus 4 times x plus 2 times x minus 8. Okay, so now we're at the point of actually subtracting, which you used to add and combine like terms, but now we're going to subtract. This negative sign needs to go through this entire parenthesis, right? So that needs to be distributed to everything. So if I'm going to change this sign to a negative, so if I'm going to add this to be a plus like this, and I'm going to distribute this negative sign all through here, it's going to be a negative and a positive and a negative and a positive because I'm subtracting everything. Okay, so I can either change the signs or I could just make sure I subtract everything, but you have to make sure you subtract everything. So x squared and negative x squared is gone. X and x is 5x plus 8x is 13, and that's 12x. So 12x, let me get my black back here. 12x. And then positive 4 and positive 8 is plus 12. Boom. X plus 4 times x minus 8 times x plus 2. And that is it. Even if I factor out a 12 on the top, it'll just be 12 times x plus 1. So there we go. Okay? And that is it. All right? So that's what you have to be careful with subtracting. You have to really remember you distribute that negative on the top when you are subtracting. Okay? All right, so here's a tricky one. This is 3 terms long here. We have to find a least common multiple between 3x, 2x, and x squared. So this is kind of another one where you can kind of say, well, I have 1 over 3 times x, 3 times x, plus 1 over, and if I factor the 6 out, 2 times 3 times x, minus 1 over x times x, okay? Then I can say, well, what do I have in common? I have 1x, 1x, and 1x, right? I have a 3 here, and that's not in common, right? I have a 2 and I have an extra x. And so really the only thing I have in common between all three of them is going to be these guys here. Okay, so I have to multiply all the rest of them by a 3 and a 2 and an x. Okay, so I'm actually going to come over here because it's a little trickier. My LCM is going to be equal to my x, which is all in common, plus I need to add the 3 to it, plus I need to add the 2 to it, plus I need to add that extra x to it, right? So that LCM is going to be equal to 6x squared. Okay? And so what I need to do is, in order to get a 6x squared here, I need to multiply the top and bottom by a 2 and an x, because I already have a 3 and an x, right? And so since I already have this guy and this guy, I need to multiply by what's missing here, the 2 and the x. So I'm missing the 2 and I'm missing the x. Okay, so I need to multiply it by top and bottom by 2 and x. Okay, or just think about, 3x times what gives me 6x squared. That's another way to think about it, okay? This guy here, I'm only missing one x, right? Just that third x, so I just have to multiply this guy by x over x, okay? This guy right here, I'm missing the 3 and the 2, so I just have to multiply top and bottom by the 3 and the 2. So I'll multiply by a 3 over 3 and the 2 over 2. So in other words, by the 6, okay? So we have this right here going to be 2x over 6. Whoops. 2. No, that's not it. That's an S. There you go. 2x over 6x squared plus x over 6x squared. And then minus, that's going to be a 6 over 6x squared. And now I have a common denominator, my LCM. Okay? So 2x plus x is going to be 3x. And then minus 6 all over my common denominator of 6x squared. Okay, so there's multiple ways you can do that. You can, find out what your LCM is and find out what do I need to multiply my denominator by to get my LCM. In this case, 2x. In this case, x. And in this case, 6. Or I can find out what's missing and multiply by it. Sometimes it's easier in these smaller terms to do, what is my LCM and multiply by it. Okay. Okay, so one more. Let's do one more subtraction. Let's go ahead and factor these top and bottom. So we have 3x minus 5. I'm going to factor this to x plus 5 times x minus 5 minus, there's that minus again, okay, 2 over x plus 5. I'm going to put this in parentheses. Okay, so we have our common factor of x plus 5. We are missing the x minus 5. So over here, we're going to multiply by what's missing. X minus 5 over x minus 5. Okay, I'll rewrite this. 3x minus 5 over x plus 5 times x minus 5 minus, and I'm going to distribute this 2. So 2x minus 5. And this, kind of think of this as a little parentheses right there. X plus 5 times x minus 5. Okay, still put this little subtraction here. Now I'm going to distribute this negative sign through here. So make sure we can add those properly. So 3x minus 5, whoop, x plus 5 times x minus 5. And then that's going to become a minus. So we're going to add a negative 2x plus 5 over x plus 5, x minus 5. So our total result is going to be 3x minus 2x, which is going to be just an x. Negative 5, positive 5 is 0 over x plus 5, x minus 5. And there we go. Okay, so that is addition and subtraction in a nutshell. Okay. So you have a 4.4 day 1 Excel. Be sure to attach all of your working answers. You should have lots of work for this one, okay? So make sure you attach all of that. And then I will see you all in the next Zoom. Have a good night. Bye-bye.